So it was in the last video that we had started analyzing graphs of two variable equations. We started looking at what X-intercepts, Y-intercepts, how to find those when you're just given the equation without any picture. We want to pick that up. We want to do a second exercise. So we're going to find X and Y-intercepts of the graph of the given two variable equation. Here we got the equation X equals Y cubed minus Y. So first X-intercepts. And then we'll do Y-intercepts. First things first, X-intercepts. How do you do that? Do you remember? Well, you set wrong color. You set the Y coordinate equal to 0, and you solve for X, right? So here we go. I'm going to have X equals. I'm going to make a template without a Y right now. Blank cubed minus blank. And in place of that blank, in place of where that Y was, I'm going to put 0. So we're filling in the Y's with zeros. Now if you do that, simplification, we got what? X on the left. 0 cubed is 0, minus 0. So you got 0 cubed minus 0. That's going to be 0. So there you have it. You have just a single X-intercept, that X equals 0. Now, let's go on the Y-intercepts. So for that, you're going to set X coordinates equal to 0. Set the X equal to 0. Solve for Y. So we go back to our equation. We're going to have a blank equals Y cubed minus Y. So in place of the X on the left-hand side, I'm going to put a red 0. So what do I have? I have 0 equals Y cubed minus Y. How can we solve this equation? 0 equals Y cubed minus Y. Well, look here at the Y cubed and the Y. Think about it, is there something in common between Y cubed and Y? Can we factor something out of Y cubed and Y? Yeah, right? You can factor a Y out. I'll put a Y, and then I'll put a parentheses and ask the question, what is left over when you factor out Y? What is left over when you factor out Y? Well, think about what times the green Y would give you the Y cubed? Well, Y squared, right? Y squared times Y would give you Y cubed, and then we'll put a minus sign. What times the green Y would give you just a single Y? 1, right? 1 times Y would give you the Y. Okay, so we factor out of the Y. We have Y squared minus 1 left. All right, so here we go. We got a red 0 equals Y times. So what about the Y squared minus 1? What about this Y squared minus 1? Well, that's a difference of two perfect squares, right? You got Y squared as a perfect square, and 1 is a perfect square. So what we do, we're going to write Y in the first pair of parentheses, Y in the second parentheses, then a 1 in the first parentheses, and a 1 in the other parentheses. One's going to be plus, one's going to be minus. So Y plus 1, Y minus 1 is the factorization for Y squared minus 1. Right, that's just difference of squares. Old news. And then we're going to take each factor that we have and set it equal to 0, right? We're going to take Y equal to 0. We're going to take Y plus 1, the second factor, equal to that 0. And finally, Y minus 1, the third factor, equal to 0. So we already got one of the Y-intercepts, Y equals 0, done for us. We just have to do the other two, right? The second one, we're going to subtract a 1 from both sides. That will give us Y equals negative 1. And then on the third factor, we're going to add 1 to both sides of that equation, and we're going to get Y equals 1. Here you literally have 3 Y-intercepts. 0, negative 1, positive 1 for your Y-intercepts. Then you got one X-intercept of 0. Right? Let's move on. Let's do a second example. Well, a third example, right? A third example. This is going to be the second one for this video, but this is actually the third example in total of finding X-intercepts and Y-intercepts. What should I look at? Let's look at the absolute value of X minus Y squared equals 0. That two variable equation. Finding X-intercepts first. That's the train. There goes the train. And then y-intercepts, second. So starting with x-intercepts, we're going to set the y-coordinate equal to 0. And solve for x. Well, let's do that. So let's see, I'm going to keep absolute value of x minus blank squared equals 0. So I got my template with y not filled in, and then we're going to fill in place of y as 0. Now think about 0 squared, right? 0 squared is nothing. It doesn't contribute. So you have just absolute value of x, left on the left, remaining on the left, I should say. Absolute value of x remaining on the left equals 0. Now, anytime you get an absolute value equation, what's inside of the absolute value bars, which is x, right? X is what's left inside of the bars. You're going to set x equal to minus the right-hand side and set x equal to plus the right-hand side. So x is equal to negative 0, x is equal to positive 0. But it turns out in reality, right, negative 0 and positive 0 are the exact same thing. So really, you just have one answer here, one x-intercept, 0, right? Negative 0 is the same as positive 0. But in general, that's how you want to solve an absolute value equation, right? You set the x equal to the negative right-hand side and the positive right-hand side. Two situations. All right, so now y-intercepts. Want to find y-intercepts. So here we're going to set for y-intercepts the x-coordinate equal to 0. And once we do that, we're going to solve for y. So here it goes. I got the absolute value of blank minus y squared equals 0. So here's my template. Here's my template. I'm going to plug in a 0 for x. All right, we take the absolute value of 0. Absolute value of 0 is 0, so absolute value of 0 does not contribute. We're going to have a minus y squared equals 0. Minus y squared equals 0. Get rid of the negative in front of the y squared. How do we do that? We're going to divide both sides by negative 1. Dividing both sides by negative 1. It's going to give me a y squared, positive, and 0 divided by negative 1 is simply 0. And then to solve that dude, we got y squared, right? That's an even power equation. An even power equation. How do we do that? Well, you drop the square, right? And when you have an even power equation, you have to remember plus or minus square root of the right-hand side, which is 0. So, plus or minus the square root of 0. That's going to be what? Plus or minus square root of 0 is 0. What is plus or minus 0? It's the same thing as 0. So you have an x-intercept of 0, a y-intercept of 0. All right, so that's another one. Now let's do a fourth example. Final example here, I guess. Let me look at a problem here. Nice little problem. Let's say we got x squared plus y to the 4th equals 81. And we want to find the x-intercepts. And we want to find the y-intercepts. So I'm going to start off with the x-intercepts. I'm going to set y equal to 0. So that means I'm going to make a template, x squared plus blank to the 4th equals 81. I'm plugging in 0 for y. 0 for y. And 0 to the 4th isn't going to give me anything, right? It's negligible. It's non-contributing, so we just get x squared on the left equals 81. So here we have an even power equation, right? X to an even power equals a number. So to solve that, I'm going to drop my power. I'm going to do what? Plus or minus, right? Remember plus or minus when you're doing even power. Square root of 81. 81. Question is, what's the square root of 81? It's 9, right? So we get plus or minus 9. 2 X-intercepts plus minus 9. And finally, the Y-intercepts. Let's do them. Set the X-coordinate equal to 0. Set the X-coordinate equal to 0 and solve for Y. So here we go. What do we got? We got blank squared plus Y to the 4th equals 81. So we got our template, and in place of the X, we're going to put a 0. Now, what's 0 squared? 0 squared is 0, so 0 squared is non-contributing, so we're left with Y to the 4th equals 81. That's another even power equation. This time the power is 4, though. 4, so we're going to drop the power, and we're going to do plus or minus, since it's an even power, plus or minus the 4th root. The 4th root of 81. Question is, what is the 4th root of 81? So we got plus or minus the 4th root of 81 here is 3. So we get 2 Y-intercepts, positive 3 and negative 3.